So Alan and Skip have been positioning the detectors for maximum solid angles because we're only running up to around 390 degrees. That's over the Curie temperature of nickel in 5.4, and the reason for that is that we saw our neutrons in 5.3 at around about 304 degrees, and the maximum reported excess heat in the recent presentation at Stanford University by Brillouin was around about 300 degrees, and they didn't see anything at 600, or much lower excess heat at 600 degrees. So we're going to work with those parameters in this experiment. And so the active side is here, and we've positioned the LN7317 directly underneath with a bit of a foil reflector, but I think the outside only gets to about 250 to 300 degrees, so this should be fine. And the lead well there is where the sodium iodide detector is, looking at that. And then if we come underneath, this is the SpecTech box that reads the sodium iodide detector information. Then what we have over here is our thermal neutron oriented Higgins detector, and behind that we have our lead box with our muon detector in, and that's positioned to look up at the reactor up here. So you can see down there it's kind of positioned up to look at the reactor there, and this is our thermal neutron Higgins detector oriented, and then the slit under here, if you can see in there, under there, is pointing up directly at the reactor body to try and increase the solid angle. And then this is the 6 lithium iodide detector, which again is pointing up to try and get its crystal oriented optimally towards the reactor. So kind of everything's in position. We have this one is 6 lithium. This is our thermal neutron detector. This is our fast neutron detector, and this hopefully is our muon detector. And then up here we have the Geiger, and this is the lead cave over here, and in that hole is the well going through to the sodium iodide detector that's buried in this lead cave.